Example 3, write an equation to describe each of the following graphs. So here are the steps that you're going to take in order to do that. First things first, identify vertex, and substitute it into y equals ax minus p squared plus q, and then substitute an exact point to solve for a. So what I mean by an exact point is, see where it's identified here? There are dots. You don't want to use this point here because you're using kind of estimation. But and here even is a little bit of estimation, but where the dots actually are. Okay? And another important point of this is choose another point not the vertex. Because in a lot of ways what we're doing here is we are inputting the information that the vertex gives us. So we need to have robust ways of gathering what that A is. So if we substitute in the vertex, we're actually going to get something that is unhelpful. It won't be helpful information. And you'll see what I mean at the end. Maybe for B, I'll substitute in the vertex, and you'll see what I mean. So for A, I see my vertex here is going to be 5, negative 4. I'm just going to identify this spot here. I like small numbers. Okay, so this is actually going to be my smallest set. So that's going to be at 2, negative 1. And just pay attention to the scales because sometimes they get a little tricky. Okay, but this one clearly here goes up 1 block. So this one is negative 1 here. Okay, so identify the vertex and substitute it into the standard form. So we have y equals a, because we don't know what the stretch factor is, a x minus, and our vertex value here is 5, so minus 5 squared, and it's negative 4, so I'm going to say minus 4. The point that I'm going to substitute in is 2, negative 1, so we're going to say sub 2, negative 1, because that's a point on our parabola. So for my y, I'm going to substitute in negative 1. So negative 1, I'm just going to, why not use some highlighters here? Negative 1, negative 1, negative 1, just so that we're all on the same page here, equals a times x, but we are going to actually substitute in our negative, or our positive 2, parenthetically there. So 2 minus 5 squared minus 4. Now we have one equation and just one variable, so we can solve for it. So I'm going to say negative 1 equals a negative 3 squared minus 4. Negative 1 equals negative 3 squared is 9, and we like the coefficient in front of the variable. 9a minus 4. Add 4 to both sides. 3 equals 9a. So then a equals, divide both sides by 9. So 3 over 9, or we can say a, clean it up a bit, give a pre-calculus answer. A equals 1/3. Just going to section off my page here. So my final answer is going to be this equation right here, but substituting my a as 1/3. So y equals 1/3 x minus 5 squared minus 4. I'm going to put a box around it so it's very clear. And that makes sense because it's not going over 1 up 1, it's actually going over 1 up 1/3. So it's flattening out a little bit. So always go back to the equation and see if your data makes sense. If it does, keep that answer. Let's look for B. Now B has an extra little spice in it because it opens downward, but we will not be tricked by that. We know that that means it's a negative number. So I'm going to say my vertex here is at 0, 3. And the other point, I don't want to deal with negatives here, so the other point that I have is going to be, see what I mean by the scale? This is 1, 1. Even though it's going over 2 and up 1, it means that every square is a half. So this one right here is going to be 1, 1. So first things first, identify the vertex and substitute it into y equals a x minus p squared plus q. So we're going to say y equals a. And don't worry about putting a negative here. It'll all come out in the wash. You'll see what I mean. I'm going to say x minus 0 squared plus q, which is 3. I'm going to clean this up a bit because I don't want those nasty mathematicians to laugh at me. Y equals a x squared plus 3. I'm going to substitute in the point 1, 1. So because that's a known point on our parabola. So I'm going to say 1 equals a times 1 squared plus 3, and I'm going to use those sweet colors because they're helpful. That's my x value. This is my y value. And now I'm just going to solve for a. So 1 equals 1 squared is just 1, a plus 3. I'm going to subtract 3 from both sides. I'm going to get negative 2. So my a equals negative 2. And that's not my final answer though. So I'm going to write y equals, instead of my a, I'm going to put in negative 2. And then x squared plus 3. That is my final answer. I could substitute into this one, but that's not the nicest, cleanest form. I want to put it into this one because we got rid of that that minus 0, which is kind of redundant. So here's the question: what if I substitute the vertex? So if I have something like y equals ax squared plus 3, and I know that my vertex is going to be at 0, 3. What I'm going to do is I'm going to substitute in all my values that I know. So I'm going to put in my 3 for my y equals a, which is what we're hoping to solve for, times 0 squared plus 3. What? Well, if I put in my vertex, my value, my p value actually takes this part of the equation to 0. So then I just get the information that 3 equals 3. Well, thank you very much, mathematical Captain Obvious. Obviously 3 equals 3. But the thing is that's so important here is that it eliminates our a variable. So we can't solve for it. So the exact thing that we're trying to look for is multiplied by 0 always if we substitute in our vertex. So this is a very important lesson as to why you want to choose another point and not the vertex.